All right, so here we are with the last section, kind of, for week 1. We're looking at modeling. Okay, so word problems. All right, one thing to note for modeling. These are 4 steps that I need to see when grading your work on your exams and on your homework. Okay, these are required to get points. So the first step would be to set up your variable. So it's called a let statement. For example, you might say, let x be the miles per hour, or something like that. So to inform your reader, me, on what your variable stands for. The second step is you need to write an equation for your problem. So you need to show an algebraic equation on how you got your answer. Then after that, you need to solve the equation. And since this is a word problem, you need to answer in word form. So you need to answer in a sentence. That's complete with a capital first letter and a period. All right? We are in college. We can do this. Okay, so let's take a look at the first kind of problem. This is called a geometry problem. Let's see why it's called that. So, a rectangular parcel of land is 6 feet longer than it is wide. Each diagonal from one corner to the opposite corner is 174 feet long. What are the dimensions of the parcel? Okay, so let's just draw a picture to get an idea of what we're looking at. We're looking at a rectangular parcel, right? What do we know about it? Well, let's see. It's 6 feet longer than it is wide. So this side, right here, is going to be 6 feet more than whatever that side is. So let's call this side W, since I don't know what it is. So that's my let statement. Let W be the width. That means that my length is going to be 6 more than W. Well, writing that out algebraically, that's just going to be W plus 6. All right, what else do we know? Each diagonal from one corner to the opposite corner is 174 feet long. So let's draw that diagonal in, and we know it's 174 feet long. All right, and what are we trying to find? We're trying to find the dimensions, okay? That's the unknown, the dimensions. So let's see, we did the let statement, check. Now we need to write an equation. This is geometry. Do I know any geometry equations that we can use these 3 sides with? Well, since this is a rectangle, I do know that that is a 90-degree angle right there. Which means this looks like a right triangle. Do we know any famous theorems with right triangles? I think one probably should pop to mind, Pythagorean Theorem. Yes, favorite one, the Pythagorean Theorem. Okay, this states that if you have a right triangle with sides A, B, and C, you can say a squared plus b squared should equal the hypotenuse squared. So we're going to go ahead and use this equation to build our own equation. All right, so I need to figure out what are my 2 sides. Well, it doesn't matter which one comes first if I use w or w plus 6, since they're both being added, and addition is commutative. I'll go ahead and just take the w part, and my theorem says to square that, plus my other leg, which is w plus 6. My theorem says to square that. And this is going to be equal to my hypotenuse squared. So what do you think the hypotenuse is? Our hypotenuse is going to be the 174. If you got that right, give yourself a little mini high five. The 174, and remember, this value is also supposed to be squared. Okay, so there we go. We have our equation, and we got this equation because we recognized that this shape was a triangle and a right triangle. So we were able to use the Pythagorean theorem to set it up. Important to note, it needs to be a right triangle to use the Pythagorean theorem. All right, so let's go ahead and solve this equation. Let's just simplify the left side here. That's going to be w squared plus, now this means w plus 6 times w plus 6. All right, and I'm going to use my calculator to multiply out 174 times 174. And what did I get? Can you see that? That value right there. 30,276. Okay. Let's go ahead and do the multiplication right here. So that's going to be FOIL. So we're going to do our first ones. Let me rewrite this, w squared. Okay, so first, w times w, w squared. Outside values, w times 6 is going to be positive 6w. Okay, now let's do the inside. 6 times w is going to be 6w again. And one last term to do. Last. 6 times 6 is going to be 36. All right, my equal signs are starting to get a little off hazard there, but we can clean that up. All right, so let's take a look at the left side. Can we combine any like terms here? Yes, we have these w squareds, and we have these 6w's that we can combine. So combining that, we get 2w squared plus 12w plus 36 equals 30,276. Okay. Now, because this is a quadratic equation, and we have both the squared term and the power 1 term, I'm going to move the 30,276 to the other side. So subtract that from both sides. And what do I get? Let's use a calculator. Minus 36. So this is actually going to be the opposite of that, so that'll be 30,240. Okay, so I have a quadratic here, and two options. I can try and factor it, or I can try the quadratic equation. For this problem, I'm going to go ahead and use the quadratic equation. So to do that, I want to see if I can simplify my terms. Do these have a value I can divide them all by? Well, they're all even, so I can divide them all by 2. So divide them all by 2, and that side by 2. What do we get? Let's see. Well, 2 divided by 2, that's just going to be w squared, plus 12 divided by 2 will be 6w, minus, and I have no idea, well, I kind of have an idea of what that is, but let's just go ahead and plug it into the calculator for that sake. 15,120. Okay, so 15,120 equals 0. All right, there's our quadratic. Now let's go ahead and plug this into the quadratic equation. If you need a little hint, I'll write it right here. Quadratic equation, or formula, excuse me. Formula. Getting a little squishy here. Formula. So it's x equals negative b plus or minus. So this should just be something you've seen before. Just a small reminder. All right, and remember, we get our a, b, and c values from here. So our a value is the number in front of w squared. Oh gosh, what's the number? That number's 1. Remember, it's that invisible 1. So that's my a value. My b value is 6. And my c value is that negative 15,120. Okay, go ahead, pause the video, see if you can plug it into the quadratic formula. All right. Oh, now we have to be careful here, because the generic equation says x equals. But that's not the variable we're using. We're using w. Okay, so be very careful when you show your work. We're going to say w equals. All right, so we're going to minus our b value, which is 6, then plus or minus square root of our b value squared, minus 4 times my a value, 1, times my c value. Ooh, remember that negative is important to keep in with our value. It is a negative. And then a little tail to show where my little square root ends. I just put that tail just so my reader can see where it ends. Divided by 2a. Okay, simplifying this. It's going to be 6 plus or minus the square root of, well, 6 squared is 36, minus, let's go ahead and type that into the calculator. Okay, so that's going to be a negative 15120 times a negative 4. I can leave out the 1 because any number times 1 is just going to be itself. But if you want to multiply it by the 1, we can do that. And what do we get? 60,480. So 60,480. And because that's positive, that's going to be a positive sign right there. And I'm going to be a little picky here. Let's shorten that that square root sign. Divided by 2. Okay, and let's see. Simplifying inside the radical, we're going to add the 36 to our 60,480. And what do we get? All right, right there. 6 plus or minus the square root of 6516, as our calculator tells us, divided by 2. All right, so now I want to figure out what the square root of this value is. So to do that, on my calculator, I'll go ahead to the caret. Let's see if you can see that. I want to go to and remember, square root is the same as the half power. So square root of a is the same as a to the half. So we're going to raise this to the half power. Okay, press enter. And what do we get? 246. Hey, that's a nice number. Okay, so equals 6 plus or minus the square root. Oh, no, we just got rid of the square root. Plus or minus 246 divided by 2. Hey, not too bad. Okay, last step, we're going to split this up into the plus and minus case. So we have one option is 6 plus the 246 divided by 2. The other option is 6 minus 246 divided by 2. Okay, let's go ahead and do those options. So 246 plus 6, 252. Dividing by 2, I get 126. So that's one option, 126. The other answer, okay, remember this is quadratic. We're going to get two answers most likely. 6 minus 246. Divide that by 2. Negative 120. All right, now this is kind of strange because we have two answers. So do both of these work for my problem? Well, in order to answer that question, what does W stand for? W is the width. Let me get my highlighter there. W is width. Now, can you have a width of 216? What units am I using? Feet? Yeah, that makes sense. Perfectly makes sense. But can you have a width of a negative 120? No, it doesn't make sense to use a negative. So that answer for our problem is going to be extraneous. And go ahead on your work. Whenever you cross out an answer, please use this word extraneous to indicate to me that you know you shouldn't be using that answer. Okay, and remember this is a word problem, so my last step, answer in a sentence. So here we go. In the limited amount of space I have left myself, let's go ahead and write a sentence. So the dimensions of the parcel, well, it's going to be 146 feet by, well, W is 146, so 126, not 46, plus 6, and that's going to equal 132. So my answer is the dimensions are 126 feet by 132 feet. And period. So notice the capital letter and the period. You could put an exclamation point if you feel like it. You won't get any extra points for that, but it does look fun. All right. Whew. Let's move on to the mixture problem. Okay, so mixture, as it sounds like, we're mixing quantities together. Okay, so please notice I have replaced the word added with replaced. So go ahead and make that note on your notes. Okay, so let's read this problem. A 100-gallon tank contains 2% bleach solution. How much solution should be drained and replaced with pure bleach to obtain a 5% bleach solution? Let's go ahead and draw out what's happening in this problem. So I've got some amount, and it's 100-gallon tank. So normally I put the amount in the bottom. So 100-gallon tank, and it contains a 2% bleach. Okay, so I'll put the percentage in the top, and I'm going to note that this is bleach. Okay. We don't want to mix the different types of percentages here. So we're going to go with the bleach percentage. So now we're trying to figure out how much we should drain. Okay, draining, is that adding or subtracting? Draining is a subtraction. So we're subtracting. Do we know how much we're subtracting? We don't. Okay, since we don't know how much it is, well, in algebra, the thing we don't know, that's usually a variable. So I don't know how many gallons. I'm going to put x gallons. Okay, and because you're showing me a diagram here, you don't need to write let x equal the number of gallons, since you already have a diagram. But if you feel like it, you can write let x equal number of gallons drained and replaced. In this case, if you had the diagram, that's enough. Okay, so we want to know how much should be drained and replaced. Okay, drained and replaced. So when we're replacing an amount, that means the exact same amount is coming back in. If I drain out x gallons and I'm replacing it, replace means to put right back. So we're going to be adding the same amount of gallons that we drained out. And we want to end up well, if we're just draining and replacing, we should end up with 100 gallons at the end, because we're draining and replacing the exact same amount. We have 100 gallons. Okay, so the only thing missing from this is the percentages on the top. So let's see, if I have 100 gallons of 2% bleach and I drain out some amount, the question is, what percent is the amount I'm draining? So here's a little picture. So let's say I have a cup. All right, I got a cup of bleach and it's 2%. And let's say you pour some on the ground, right? It's pouring onto the ground, creating a little puddle of mud and what have you. This is kind of fun to draw. Okay, so what is the percent of bleach coming out? What percent is coming out? Well, it doesn't change as I pour it out, right? The amount coming out and landing on the ground, that should still be 2% bleach. Okay, so the amount pouring out is 2% bleach. So how much should be drained and replaced with pure bleach? Okay, so I'm replacing this with pure bleach. So if it's pure, if you're like a pure blood, right? It'd be 100% of something. If it's pure chocolate, it's 100% chocolate. So this is 100%. It is pure. We're replacing it with 100%. And we want to end up with a 5% bleach solution. So 5%. All right, and there we go. This is our diagram set up. So now we need to create the equation. So easy thing when you set up a mixture problem, it's kind of nice because when you set it up like this, all you do is you take the percent and you multiply it to your amount. So let's go ahead and do that.